All right, welcome back to this video. In this video, we're going to consider how we prepare our data for modeling or to build models. All right. So previously, as we talked about, there are some imbalance in our imbalanced data in our data set, and we're going to use the pie chart to actually visualize this before we move on building the algorithm. All right. So let's start. Let me show you how the final output so that we can actually deal with it along with the code. All right, so we're going to see over here that we have about 99.8% of the data points in class column that consist of not fraud cases, which obviously is expected that most of the transactions are going to be normal transactions, and few of them, which is around 2%, are going to be fraud cases. All right, but irrespective of the fact that it's very small, is 2%, we still want to spot that and then be able to eliminate that. All right, so that's what we are going to do over here. So we are saying that go into the df column, and if you see anything which is equal to 1, find the length of that and store it in fraud. All right, so if you remember from previous video, we selected only class, amount, and then the class and the amount and the time. Right, we stored everything in a variable called df. Right, if we go all the way up here, we can actually find out that we stored only the class, the amount, and then the class amount and time. We stored everything in a variable called df. All right, so that's exactly what we are going to do here, that we're going to go into this column, which is called class column, and then if we find anything which is equivalent to 1, right, which is equivalent to 1, then we store it, we find the length of that and store it in what is called fraud. Right, so that becomes the fraud, and then the not fraud, which represents 0, right, which is the normal cases, which is very huge. Right, we store everything in a variable called not fraud. All right, and then after that, we actually create some labels. All right, so you can see over here fraud and then not fraud. So these labels are what we can see here, fraud and then not fraud. All right, okay, and then after that we set the sizes. So the sizes are just going to be the length of this, right, the length of that. So if we check, for instance, let me show you the length of this, the length of 1, right, those that are equivalent to 1. All right, so okay, sorry for that. Let me go up a bit again. Okay, so it's just collapsing here. All right, so yeah, we can actually come down here. So what I want to do is to actually show you something like this. Okay, now if we check the length of this, right, if we check the length of this, and then some L here, now we can see that we have 492 as expected. Right, we remember we did that in the previous video, and then we're having 492 ones, and then 284,315 zeros. Right, so we store that length in a variable called fraud. All right, so that's what we are doing here, and then we do the same thing for not fraud. Okay, so if you check this one too, you'll find the same thing here. Right, and then these labels are just the labels that you can see here, not fraud and then fraud. All right, that's what is going to happen. So after that, we put these ones, fraud and not fraud, we put them in a list form like this. Right, and then we store everything in sizes, and we're going to use that in a moment over here. Okay, now after that, we set the figure size. All right, so that we see the size of this. That's why we see 10 and then 10 by 8. All right, so we can actually change that, and then you can see, maybe let me change it to a very small number, say 5 by 3, something like that. Now if I run this again, you can see that it's very, very small now. Okay, so this is just checking, setting the size. So let me set it to the 10 by 8. All right, so this is more visible. And then after that, we are using what is called a pi, or the pi function, which is present in matplotlib. Right, and then we set the size. Remember the size, we are saying that the size should be fraud and then not fraud. Right, and then we set the labels that we've already defined as the fraud and not fraud over here, so that it will be here for us. Okay, then after that, we are just setting down to one significant figures. All right, just so that we will be having only one decimal point after this, so that we will not be having, say, 99.8745 or something like that, a lot of decimal points. I just want only one after the decimal point, so only one significant figures over here, 1.1, and then after that, just like this one too here, 0.2, not 0.2001 or 7 or something like that. Some infinitesimal decimal points are going to come before after that, and I don't want that. Okay, And then we are saying that shadow to be true, right? We have shadow to be true, which is this shadow that you're seeing here. All right, this shadow that you're seeing over here. All right, this shadow that you're seeing over here, that's what you're setting over there. And then start angle is 0, so that is to start from 0 like that. Okay, if you can even change it to say 90, right, so that it will be in the 90 form. So if I change it to 90, you can see that how it is being oriented for you. All right, so all these are just hyperparameters that you can just change. All right, all these are hyperparameters that you can change, and then these are just title, that's your ratio, and I mean fraud versus non-fraud. So you can change any of the hyperparameters that we have over here. All right, so the basic idea here is to see that we have only 2% of fraud cases as against 99.8%. All right, so let's start with our algorithm, preparing our data for algorithm. So the first thing we have to do is to separate our data into dependent and independent variables. All right, so everything apart from the class, all right, everything apart from the class, we're going to store it in a variable called x. Okay, and then the class column, we store it in a variable called y. Okay, then after that we can do our training and testing. Okay, so we're going to use this x and y here. Okay, we're going to use part of the x to make to train our model, right? So the part that we use to train our model, we store it in what is called strain, and the part that we use to test our model, we store it in what is called test. And then the same thing for the y, the part that we use for training, we store it in what is called the y train, and then the part that we use for testing, we're going to store it in what is called the y test. All right, what is called the y test over here. All right, and then we set the test size to be 25, meaning that we're going to use we are just going to divide our data set into 75% as against 25%. All right, so 75 for training, okay, 75 for training, and then 25 for testing. Okay, so that is what is going to happen here. That's why you're setting the test size to be 0.25 rather. Okay, and this is going to be done randomly. All right, so we want to get to the same random numbers as we generate or run this code over and over again. All right, we want to get to the same random numbers over and over again. So that's why we set random state to be equal to any number at all. All right, and then that's it for dividing our data set into training and then testing. And then after that, what we're going to do is to actually put the training and the test, I mean the x train and the y train together. You can actually ignore this part. It's not actually I mean, there's a different way you can do it without actually putting them together before moving on, but you can actually do that and just visualize the first 5 rows of it. All right, it's not a mandatory thing. Okay, so over here what we're going to do is to actually without dealing with any imbalance, or remember we have 98% of our data, 99.8% to be not fraud, and then only 2% to be fraud. All right, so what we're going to actually do is to actually deal with this, but before we deal with that, we can actually use what is called the dummy classifier to actually verify this imbalance data. All right, so we're going to use that one, and then we are going to import it from the dummy. All right, so sklearn.dummy, we are going to import what is called the dummy classifier, and then use it to build an algorithm, and then see how well it is going to do, and see the predictions that it's going to do. So as you always see, always know, we're going to actually initialize it. So that's what this part is doing. So here we are doing it at the same time, initializing and fitting it at the same time. All right, initializing and fitting it at the same time. At the normal sequence, you might be seeing this one down here, and then we use this dummy, all right, to say fit it, something like this, right? But this is another way of also doing it, right, without actually without doing that. You can also do the same thing on the same line at the same time. All right, okay, then after that you can also make predictions. Since we have created our model dummy, we can also use it to make predictions on the x test. All right, this is the data that our model has not learned from it, so we can also make predictions on that. Okay, then after that we can also see the unique values that is predicting. Okay, so after making the predictions, we store everything in what is called the dummy pred. All right, and dummy underscore pred. So we store every prediction over there, right? So push to predict zeros and ones. All right, so that's what we store over here. Okay, then after that, or maybe I can just run this one so that you can see what is happening over here. Okay, so let me minimize this a bit and then create another one. undo. Okay, and then I'll just show you what is happening here. So you can see that it's predicting some zeros and ones over here. All right, it's predicting some zeros and then ones over here. All right, so I'm going to get rid of that, and then this what we stored in this dummy pred. Okay, then after that we can check the unique predictions that is actually doing. All right, the unique predictions. You can see that this one is actually going to predict most of the zeros because it's more of that, and then check the accuracy score. All right, so if we do that, we can see that you're having around 99.8%, right, almost 100% over here. Okay, almost 100%, just like we have over here, 99.8%. So it's just predicting all the not fraud and ignoring this. Right, so if we use any other algorithm, that's what's going to happen. It's going to ignore the fraud and it's going to predict only the not fraud cases. All right, that's what it's actually going to predict, and that's what we are trying to prevent here. So it's predicting only zeros, right, and then ignoring the ones. Okay, so it's predicting the 99.8%. That's what actually is doing, and that's what this pie chart is actually showing us over there. So we can start by doing the upsampling and the downsampling, and then get our data to be balanced. All right. So over here we're going to use a function called, a package called resample. All right, that's what we're going to use to do this upsampling. All right, so we have two concepts here that we're talking about: upsampling and then downsampling. So let me just do something small so that you get to understand this upsampling and downsampling here. All right, so when we're talking about the upsampling, let's say we have one. So let me put it here. Let's say we have 1. All right, we have 1, and then we have 0. Okay, now let me bring this one. Okay, so let's say I want to lie. So let's say our 0 is as high as this. Okay, then let me bring this, change the color here, and then let's say our 1 is somewhere here. Okay, our 1 is somewhere here. Now what upsampling is actually doing is that we want to actually upsample, like take sample of the ones which are very small. All right, and then increase it, right, just take some sample out of that and then increase it to get to the same level as the ones that are having a lot of them, right, get to the same level. So we are upsampling, taking some samples out of the one and then regenerate it and then make it at the same level. So this is what we call the upsampling. Right, this is the whole idea around it. All right. Some people also call it oversampling. So if you see oversampling, it's just the same thing. Upsampling, oversampling, the same thing, right? And then the downsampling, right? The downsampling. Let me just pick this one and then do it again here, so that you see the difference between this. So let's say we have this and that, right, and 0 here, and then let me do the same. Okay, so let's say our one is like this. All right, that's the length of our one, and then our 0, right, which is having a lot of them, is like that, right? So what downsampling is actually doing is that for the ones that are having high values, reduce it. So reduce it so that it will be down. It will be down to the one that is having low low data points in there. So that's down sampling, right, reducing it down. Okay, so that at the end of the day they will all have the same samples, right? They will become the same level, right? They will become the same level. So this is what we call the down sampling. All right, and some people also call it undersampling. So if you see undersampling, it's the same thing as downsampling. So that's what we're going to do over here, right? So we're going to use the resample package, all right? And then we're going into the class column, right? So we're going to into the class column, and then anything that is equivalent to 0, we store it in what is called not fraud. Remember, 0 represents not fraud, and then 1 represents fraud, right? So we pick everything that is equivalent to 1, and then we store it in what is called fraud. All right, then after that we start to do our upsampling, and then we are going to store everything in what is called the fraud under fraud upsample. This one is just a variable that I created. You can create any variable at all. All right, you can just choose any name at all, but this is just a name that I chose. Okay, and then we're using the package here, which is resample. All right, we're using that. And then remember, we not fraud is the one with less values, right? That is the one. So we're going to make sure that that one comes up, right? That one comes up, and then match the one which was tall, all right? So which was having number of data points. So we're going to use that one, and then we want replace equals true means that let's say this is the bag that is containing both of ones and zeros, right? That is fraud and not fraud. So if we pick that, remember we are doing this sample, we are sampling, right? And then we are going to do this randomly, and if we pick anything out, if we pick any data point out, and then that becomes a sample, right? If we want to go and pick another one, what we are saying that put it back, right, before you pick another one. That's why you're saying the replace equals true. So we are sample with replacement. Okay, and then let the length be equal to the one that is having the higher length. So we are saying that let this small one, the length of this, be equivalent to this one, right? Remember the one with zeros, right? That's the one that is having higher value. So let the length be equal to that, right? So the end samples length should be equal to that, all right? And we're going to do this randomly. So we set random state so that we have the same random values over and over again. All right, then after that we put them together. That is we use the concat to put the not fraud and then the fraud upsampled. All right, so this new one becomes the values for this one. Okay, so we're going to put this and then that together. Okay, that's what we're doing here, and then we name the new data set as upsampled. All right, now if we check the upsampled.class.value count, right? If we check the how many zeros and ones are there, let me just scroll down a bit so that we can see. All right, now we check that. Now you can see that we have equal number of zeros and ones in there. Okay, so this is what we are. This is what we call the upsampled, right? Making the small values equal to the bigger ones. All right, the ones with higher length of value. Remember, these values are 213 and 213,245, and not like we were seeing earlier on, because we did this concat here after dividing our data set into training and testing, right? Over here, right, we added this and then we store it in X, right? So this, obviously these values are not the same as earlier on, but whatever is in there is still going to be more than whatever is in the fraud is going to be lesser than whatever is in not fraud. Right, so not fraud is actually going to be more, and then fraudulent cases are going to be less. So we're going to match. What we're doing here is matching the fraud cases with the not fraud cases. All right, so over here we've been able to make sure that all these data points are, all these length of the zeros and ones are the same. All right, so now we have a fair data set and we can build algorithm on it. All right, so let's move on and then do that. Now what we're going to do over here is to start with what is called the logistic regression. Right, we're going to start with what is called the logistic regression and then use it to build algorithms. So we're going to import this package which is called logistic regression, which is present in sklearn.linear model. All right, and then we're going to use that one. So in upsampled is what we did earlier on, right? Remember over there, that's what we did earlier on. So upsampled.class, we're just selecting the class and then we store it in what's called a Y train. Right, and then we, apart from the class, everything else becomes X. Right, we store it in X train. That's what we're going to actually use to build the algorithm here. All right, and then we're using this logistic regression function here. All right, and then there are different solvers that you can use, right? In this case, we're going to use what is called linear. If you're not aware of the various solvers that you can use, you can just check the documentation for logistic regression. You can see different solvers that you can use, right? Then after that, we're using the fit to start to build algorithm or let algorithm to learn from the training data. Okay, then after that we make some predictions, right? Remember, we store everything in upsampled, so upsampled becomes our model. Then we use that one to make predictions on the X test. All right, then we store everything in another variable called upsampled pre and upsampled underscore pred. All right, that becomes our prediction values. I mean, our prediction values are being stored over here. Okay, so let me get rid of this, and then we see what we have over here. All right, so we can check the score of this. Right now, if we check the score, we can see that we have around 98%. Right, we have around 98%. Okay, now we can also build the classification report for this. We can build a classification report for this. So over here, what it's doing is that we import the classification report from metrics. Remember, we first imported metrics up here, right, when we started, and talking about this library, so we first imported metrics over there. Okay, so we're going to use that one down here, and in metrics we are going to import what is called the let me go all the way here. We're going to import the classification report. Okay, we're going to import the classification report. Now what this part is, let me get rid of that, and then we can have, okay, so over here we're just printing the title Logistic Regression Classification Report, which is this one, Logistic Regression Classification Report. Okay, this is just a line that I created so that to separate the title from this. So this is just a line. I just created 1 2 3, and then I duplicated it, right? I just created this. Okay, I just created it, then I duplicated it 10 times, okay, to get this line. Okay, then after that I have the classification report, and then I use that function on y test and then on sampled pred, which is the predictions that we did, and then store it in a variable called on sampled pred. Now when we do that, we can see that we have precision here, we have recall, and then F1 score. All right, so the precision is considering one, how many ones were we able to actually identify as one. I mean zeros, considering zero, how many zeros were we actually considered, how to what extent were we able to identify zeros as zeros, and then to what extent were we able, precisely identify one as one. So we can see that at 100% of the time we're able to identify zeros as zeros. Obviously zeros are very much dominated, and we're able to going to be able to see zeros more. All right, and then you can see that at 8% of the time we're able to see one as one. All right, and then recall is how well is our model able to recall zero, or remember or identify zero as zero, and then how well is our model able to recall or identify or remember one as one. And that is what it's actually doing here. All right, so at 98% of the time our model is able to recall or remember or identify zero as zero, and then at 87% of the time our model is actually able to remember or identify or recall one as one. Okay, now F1 score is just a weighted average of precision and recall. All right, so it's just a weighted average of precision and recall. Okay, so at 99% of the time, so you can actually use only the F1 score to even get to know how well the model is actually doing. So at 99% of the time we're able to actually predict 0 and 0, but at only 14% were we able to actually predict 1 as 1. All right, and then these are just the values that we're presenting there. Okay, so moving on down here, let me get rid of this. Okay, now after that we can build a confusion matrix on this, right? We can build a confusion matrix on this and then see how it is working. So we're going to use the function called confusion matrix. We've already imported confusion matrix earlier on when we're dealing with when we're importing the various libraries. So let me just quickly go up there so that you can easily see it. All right, so over here you can see over here that we have confusion matrix being imported here. All right, so let me just maybe cut it and then go and put it down there for you so that you can easily see that we have it over there. All right, so let's go all the way down, minimize it a bit, then let's go all the way down here. All right, so this is what we're going to use over here, right? So if I do this, then I can place it there. So we're going to import this confusion matrix from sklearn.matrix. right? We're going to import this confusion matrix, right? Then after that, we're using that confusion matrix to plot the confusion matrix based on the y-test, and then the unsampled is just unsampled underscore pred is just a prediction that we did. Now when we do that, we can see over here that let me zoom this thing in. Okay, this is fine. Get rid of that. Now over here we can see that for zeros we were able to predict, so 0 here at 69,717 of the zeros we're able to predict as zeros. All right, we're able to predict as zeros. However, 1,300 of the zeros we predicted them to be ones, right? So this part is actually a wrong prediction. All right, that's a wrong prediction on this part. All right, so 69,717 of the zeros were able to predict as zeros, but 1,353 of the zeros we predicted it as 1. All right, so if you see over here, we can see that ones of the ones, right, 115 of the ones we were able to predict as 1, but 17 of the ones we predicted as 0. All right, 17 of the ones we predicted as 0. Okay, 17 of the ones we predicted as 0. Okay, so 17 of the ones, instead of predicting them as ones, we predicted them as zeros. All right, and then 115 of them we predicted them as 1. All right, so this is a mistake, and this is a mistake, and what we are trying to do is actually minimize this one. Right, this is the most important one to minimize here. All right, this is the most important one to actually minimize, because if it is a fraudulent case and then our algorithm is saying that it's not fraudulent, then that's a red flag, right? It's going to help people get away with it, or we will start to lose money without actually knowing where it's coming from, because our algorithm is mistakenly saying that some of the transactions that were actually fraudulent transactions, our algorithm is actually saying that they were not fraudulent transactions. So what we're trying to do is to actually minimize it. Right, so if we have any algorithm that is having lesser of these wrong predictions, then that algorithm is doing better. Okay,